Here we go. So basically, if you remember last time, okay, what we did, I think this is where we left off, mostly because I think we ran out of time, and I think there was a mistake I had made in this slide. So I figured it'd be good to start from here. So basically, let me go back to this. Here we go. So essentially, the main idea that we saw last time was this. Equations. Basically, if you have any equation, okay, in the Cartesian plane, any line in the Cartesian plane, that line, the graph of it can be written in this form. Ax plus by plus c equals 0. A and b and c are numbers. A and b cannot both be 0 at the same time. So any line in the Cartesian plane, vertical, horizontal, or any other line, the equation of it will be of this form. And also, if you were to graph this equation in the plane, sketch the graph of this equation, you will get a line. What the line is will depend on A, B, and C, of course, but you will get a line. And that's really what I started showing last time. I mean, graphing a line is actually not that bad. You just get two different points on the line and then connect them. Once you have two different points on that line, you're good. You just connect it. I mean, it turns out a line, the line is uniquely determined by two different points in the Cartesian plane. You just connect them, like connecting the dots. So I think we did this one last time. So here's this one. I mean, I'm not really going to emphasize sketching a graph by hand so much, mostly because this is an online class. And I figured, you have Desmos, GeoGebra, there's lots of ways to have a computer sketch it for you. But I do want to emphasize, working with the equations. So let's consider this one. So we want to sketch the graph of this, let's say, okay? I mean, yes, you can, how do I say? You could have a graph, software like Desmos or GeoGebra graph this for you. Let's get two different points on the line. So, I mean, you could just directly replace x by something, solve for y, replace y by something, solve for x. You could do that. What I'm doing here is I'm getting y in terms of x. I mean, from what I have seen teaching this class before, most students tend to do that anyway. So I figured it wouldn't hurt to do that. So that's what I'm doing here. So basically, again, I'm getting y all alone on one side of the equation. I subtract 5x from each side here, right? We want to get y all alone. Then we subtract 4y. Then we're not there yet. We get minus 4y is 10 minus 5x. Now we're not quite there yet because we want to get y in terms of x. I mean, really, I guess we don't have to, since we want to find two different points on the line. Okay? But from here, we can divide both sides by -4, and we get y. Okay, we're dividing by -4. We get y is equal to -10/4 minus 5x/4, or 5x over -4, same thing. Negative becomes a positive, and so we get -10/4 plus 5x/4. I just wrote it this way. So now it's in the form y equals mx plus b. Okay. I mean, again, you really don't have to go from here all the way down here. I mean, in the past, I've said to students, just pick x to be something like 0, determine y. You get 1 point on the line, and pick y to be something, find x. You get something else on the line, and then you just connect them. That's all you really have to do. I do this because, again, students tend to do it anyway. So now we're going to get 2 points on the line. So I said, okay, well, let's take x to be 0. Then we want to figure out what y is. So we're looking for the point on the line when x is 0. We get y, you replace x by 0. Get y is 0 minus 10 over 4. So we're replacing x by 0. 5x over 4 is gone. And we get this. Minus 10 over 4. And so, of course, as a decimal, that's minus 2.5. But this is telling us this point has to be on the line. So even without graphing this, we found a point on that line. Basically, we found a solution to this equation, which is an ordered pair that satisfies the equation. Now, here we want another point on the line. So I said, okay, well, let's let y be 0 and see what happens. Or if we set y to be 0, then we have this equation to solve, as you can see. Okay, so that's what this work is doing. Basically here, I just basically interchange both sides. It's good. You really want to have the unknown on the left side of the equation. So of course, what did I do? I cleared denominators by multiplying both sides by 4. 4 times 0 is 0. I distribute. And so the denominators are now gone. And I don't know why that's a 5 there. That should be a 4. Let me just quickly fix that. It's been a typo. That happens. But once you do that, you're going to get 5 times x minus 10 is 0. We get 5 times x minus 10 is 0. Now, remember, what you also want to do is you want to show your work. In this class, you want to make sure you show your work on a quiz, exam, or whatever. I mean, you could probably just tell by looking at this, oh, x has to be 2. But show the work, please, okay? So here I'm actually showing, yeah, x has to be 2. You add 10 to both sides, right? You get 5x is 10, divide by 5. You get x, yeah, is 2. So from here, what we get is this point is also on the line. We have 0 minus 2.5. We have 2, 0. We have 2 points on the line. And now we can actually sketch it using, Desmos, GeoGebra, or even by hand. But if you do that, you end up with this. I did label the points, as you can see. I mean, I hope you can see it. It may be kind of tricky to see, but basically this is what we get. We get this line. All right, so that's good. I hope that makes sense. I think we should do another example, but are there any questions? Remember, I can't see the chat, so if you have a question, use that the hand raise feature. Okay. I mean, essentially, that's all the new stuff from 2.3. I want to do some more examples, and I do have a worksheet. I figured, I can let you guys work on like 2 or 3 or 4 problems. I like to give examples for people to work on in class. Here's another one, and I'll let you try one. But now it's basically the same problem, except I guess, you have, same problem type, I should say. So from here, we have 2x, right? Plus 9 times y is 12. We're going to sketch the graph of this, and right away you should know, oh, we're going to get a line, right? I mean, if you went back to that general form, ax plus by equals c, you can see that this fits that criteria. Really, what gives it away is it's an equation in 2 variables, and both powers of the variables, the x and y, are 1. I mean, we'll see this in chapter 3, but if you had x squared here and y here, you would actually get a quadratic. the graph would look like would be a parabola. That's a different story. Here, so I'm going to proceed the same way. I'm going to get y in terms of x, right? So here, that's what I'm doing. I'm subtracting x from both sides, as you can see, and you get 9y is 12 minus 2x, as you can see. But we want y, we don't want 9y, so we divide by 9, as you can see. So here the 9's cancel. We get y is 12 over 9 minus 2x over 9. And then, of course, I just interchange it. Subtraction is the same as adding the negative, so I just switch the order. Mostly because now it's in mx plus b. And again, you really can take x to be you could take x to be 0 and another number if you want. You just have to somehow get 2 different points on the line. I mean, what I do here is kind of like what I did in the previous example. I take x to be 0 and find y. And I take y to be 0 and find x. I mean, that might be more work than necessary. So anyway, before we do that, let me just pause the recording